Morning, maths meeple. Yes, that was a mixture of mathematician and maths people, and it came out with maths meeple, which is what I'm now going to call you. So today we are on binomial distribution for the first years, and then for the second years, normal distribution. These are the two key parts of the statistics specification. So the stats is worth 1/6, not much at all. All of stats, it's only worth 1/6 of your overall marks. But within that, the normal distribution and the binomial distribution is a huge proportion. Okay, so it's well worth putting time in. I would say if a student who only had a week, just don't bother with data, don't bother with sampling techniques, correlation, maybe have a quick look at probability, but just make sure you can do binomial and normal, because that gets you loads and loads of the marks. I am really light again because I'll try and move a little bit. I tried to put curtains up so it wasn't streaming at you, but it turns out my walls are made of dust. So it was really difficult and it didn't work. So I'm going to keep trying and see if I can get the curtains up so that in the mornings when I'm talking to you, I don't look like I'm in heaven. Right. Let's go. So here is the overall picture that we looked at yesterday. All of the stats and the mechanics, stats on the left, mechanics on the right. Today we're looking at the binomial and the normal, which are the biggies. So in the Tailored Tutors course for the next 24 hours, the following will be free. For binomial, it is lesson number 53, 54, 55. And those three cover the whole of the binomial distribution. And for the normal distribution, it's going to be 45, 46, 47, 48. And that's second year numbers, whereas this is first year numbers. And that covers the whole of the normal distribution. And they're all going to be, they're all turned on. I've turned them all on. So you can use the button in the exambulance that says take me into the content guide, and then those ones will be watchable. So basically today, in the next 24 hours, you can make a complete set of notes covering absolutely everything on binomial in 30 minutes and on normal in 40 minutes, which is not at all bad, is it? What we're going to do in this session is we're going to go through some standard questions, and you are going to be doing them yourself. I'm going to be talking you through it, but I want you to have a calculator, because everything in this topic is about what you type into your calculator, basically. If you type the right thing into your calculator, and that's it, there's nothing else. There's no sort of magical techniques or manipulation or algebra or memorizing. It's just understanding what buttons to push in your calculator. So make sure you've got your calculator on you. You could have the Class Whiz, which is the most common one, or your Casio, what's it called, FXCG50 or FXCG20, either of those. I'll be able to talk you through what buttons to push. So, action hour. Rules of action hours, 45 minutes only. You have to stop when it says stop, and you have a clear target. So our clear target is to have covered all of the content for binomial distribution in the next 45 minutes and learned how to use the calculator to answer various questions. Go. Okay. You need your calculator and a pen and a pencil. Yes, Jacqueline, these questions are all in the content guide. So every lesson in the content guide has got 3 exam questions to give you an idea of the sorts of questions that come up. So I've just picked a few of those. So if you look, when you're looking in the content guide at these 3, you'll see that there's a apprentice, expert and master question on each of them. So I've just picked a few of those. So you will know when you go into the content guide, you'll know which ones you've done. They probably are not in the exam guide. They're old spec ones, but the spec is exactly the same as it used to be. So it's the same. Right. Piece of advice number 1 about the binomial distribution, or anything to do with the binomial distribution, is this guy here. And I battle with students that I'm teaching we have a huge fight about this, me and my students, because they don't do it. They don't want to do it. They want to jump straight to here. And really, it does take me until close to the exam when they're doing quite hard questions and getting stuck. And every time they get stuck, I say, well, it's because you didn't write that down. And then I point out that if they'd written that down, it would be a lot easier. And then reluctantly, maybe some students do start doing it. So if you would like to speed up your ability with this particular topic, this is my recommendation, that you always force yourself to write this. So it helps you to think about what a binomial distribution is. The binomial distribution is always measuring the number of things out of this many. And this can change, and this you decide yourself, but it's always that structure. It's the number of things out of this. Okay. N, that's that number there. That's the number of trials. That's how many, that's the most I could possibly get, basically. And it has to be a fixed number of trials. That's the rule. So let's have a look at this example here. This is the trouble with these questions. It's like, blah, words. Where's the maths? Right. Blah, 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 blah. 30 adults. 30 adults. So N is 30. I am picking 30 adults. There is a fixed number of trials. Each adult is a trial. Each adult, I'm going to say, do you or do you not have blonde hair? So what I'm measuring is the number of adults with blonde hair out of 30. That's what I'm modeling. And if you get used to writing that, I promise you, especially when we do current bunk questions in a bit, it will be much, much easier. So this is sentence number 1. We're always trying to fill this in. That's why we're reading the words, even though they're silly words. X is the number of adults with blonde hair out of 30. Now, this 30 might change to 50, or we might only pick 10 people. So that would be a different thing that we're putting in the calculator. And also we might shift our focus. We might shift our focus from blonde hair to not blonde hair, in which case we've got to be really careful how we translate the problem that we're going to type into the calculator. So that's why this is so important. Now, this information is what goes into the calculator. So on your calculator, you press on this one, you press menu 7, and that gets you the distribution, the statistics menu, basically. And you should see normal PD, normal CD, inverse normal, normal PD. And then if you press down, you get binomial CD, Poisson, Poisson. You don't need to worry about Poisson. It's not in the spec anymore. Okay, so the only decision that you need to make here is whether we want number 4, which is the binomial PD, or going to the next menu, number 1, which is binomial CD. That's your only decision, first of all. And the way that you choose it is that it's either going to be exactly or less than or equal to. So if it says exactly, then you want binomial PD. If it says less than or equal to, you want binomial CD. I'm just going to put that over here, because we don't actually have any questions that say less than or equal to at the moment. So equal to is PD, less than or equal to is CD. When you press that, so like for part A, if you pressed number 4, binomial PD, and then it's going to say, do you want a list or a variable? And you say number 2, please, a variable. If anyone's got the Casio or like any other calculator that they want me to explain how to do it, then that's fine. Just give me a shout, okay? So can you use your calculator and see if you can get the answer to question 1 literally by just typing it into the calculator? Tell the calculator what the number of trials is. Tell the calculator what P is. Oh, just need to mute myself, otherwise I'll be talking to you twice. And then press equals, and we'll see what you get. So I want all of these questions, I want you to be like doing it yourself, so that we can make sure that you know what you're doing. Okay. Now the answer is, I'm going to just talk through these and tell you what you should be doing, but I want you to be getting the answers. That's really, really important. Okay. The answer for the first one is 0.1047. I'll do it in green. And for now, don't worry about how the calculator is doing it or what the calculator is doing, because as I say, this topic is almost exclusively calculator use. So if you can recognize that you've got a binomial situation and you know what buttons to push on your calculator, then you're totally fine. Okay, so that's that one. Hopefully you got that one right. If not, do feel free to ask. Next, fewer than 10. Now, this is where binomial distribution gets a little bit fiddly because we only have two buttons. We have a button for less than or equal to and a button for equal to, and that's it. And this question says fewer than. So this is my top tip number 2. Top tip number 1 is this one, which is that if we always force ourselves to write down what it is that we're modeling, then it's going to help when the questions get more complicated. Tip number 2 is that when we are not in a situation where we have less than or equal to, we draw a little number line. Okay. So the number line looks like this, just roughly around 10. So I'm going to go 8, 9, 10, 11, 12. And then put a box around the bit that you want. Now, not only is this going to help you with binomial, I absolutely promise you it will, it's also going to help you when you do normal distribution in the second year and you need to use the continuity correction, because it's going to make the continuity correction just done. It's going to do it for you. So don't worry about that now because it's in the second year. And if you're in AQA, you don't have to do the continuity correction at all. So yes, you're completely right. On the previous one, it's 5. So the chance it's equal to, the probability that it's equal to, then the X is the thing that you want it to be equal to or less than or equal to. N is the number of trials. P, when it asks for P is the chance of success. So this I'm going to call success. That's that thing there. And P is the chance of success. N is the number of trials, and P is the probability of success. Right, so we're going to put this number around what we want, fewer than 10. Fewer than 10. So it's this lot here. It's variable, Lawrence, that you want. Variable, not list. List is where you're, you don't need to worry about list. List is where you don't have the whole distribution. You've just got some information and you're putting it in. Yes, perfect. So once you put this box round, it's really, really simple to see what it is you need to put into the calculator. Don't forget, the calculator only does equal or less than or equal. And this number line is basically the key. So on this one, number B, you're going to type into your calculator. You're going to tell it what the N is, tell it what the P is, obviously, tell it that it's binomial. And then, because you've drawn out your number line, you know what to say you want less than or equal to. All right, the answer to part B is 0.7758. We're going to get harder, obviously, here. This is going to build up, but I just want you to know how to use your calculators and what this main trick is of writing out the number line. Okay, next one. Same problem here. We don't have a question saying what's the probability that it is this number or what is the probability it's less than or equal to this number. We've got this phrasing here. So we draw out the number line. We need something roughly near 6 and something roughly near 12. So I'm going to go 4, 5, 6, 7, 8. I mean, you could even go like this, ... Say it went up to like 60. You wouldn't want to write them all out. But then I'll do like 10, 11, 12, 13, 14, something like that. And then you have a look at your number line and you look at what it says and just try not to think mathematically. Try to think literally logically. If I send you out to buy me something and say, can you get me at least 6, but at most 12? How many do I want? Well, at least 6. At least 6. So if you get me 5, I'm going to say to you, but I said at least 6. So at least 6 would be this end. And then at the other end, at most 12. I'm telling you not to get me 13. But as I say, try not to think mathematically at all. Try to think properly, like just like a normal human, and it makes it a lot easier. Right, here's the situation we are in. We cannot type that into the calculator, okay? We can only type in less than or equal to. So this is where you have to think just intelligently. How are you going to get this information out of the calculator? Well, I could do this. I could put this in the calculator. CD is where you want less than or equal to, less than or equal to. So in this one, we did use CD, but only because we looked at this number line and we were like, actually fewer than 10 is less than or equal to 9, okay? So less than or equal to 9 is actually what they're asking for here. And honestly, you see this written in textbooks, it's so confusing. It's things like if the probability that x is strictly less than n is equal to the probability that x is less than or equal to n minus 1, and the probability that x is bigger than n is 1 minus the probability that x is less than or equal. Oh my goodness. Can you imagine trying to learn all this stuff? It's just horrible. Whereas just a simple number line, it's just perfect. Okay, so what you should be putting in your calculator is, calculator, please tell me what is the probability of less than or equal to 12. And then what we want to do is get this lot chopped off the end. We do not want this lot. So then you would do the probability that it's less than or equal to 5. And then the difference between those two is the answer. And you should get 0.4857. No, that's not true. Sorry. No, that is true. Wait, I'm looking at the wrong one. Yeah, no, blonde hair. The first one, 0.1047. The second one, wait, did anybody get the second one right? Yeah, you're completely right. I looked at the wrong question. This one is not that at all. This one is 0.7758. You must have been thinking, what the hell did I do wrong? And you didn't do anything wrong. It was me. I can't copy answers. 8034 is the answer to B. Sorry about that. Part B, fewer than 10. So the calculator won't tell you fewer than 10. It will not tell you that. It only tells you less than or equal. So that's why we draw out this number line. We put a box around the things that are fewer than 10. We realize that fewer than 10 is actually less than or equal to 9. And then you put 9 into your calculator. 9 is the x that it tells you less than or equal to. The answer to part B is 0.8034. I apologize. The answer to part C is where we use the calculator to go all the way up to 12, but then remove all the way up to 5. And the answer is 0.7758. Now that more or less covers it, okay? More or less covers it, but sometimes we have to think, and it becomes more important that you've written this guy out here, and you have to think a little bit more carefully about your number line that you write down. But what we've got there more or less covers it. Right, next. Okay. What is x the number of? This is how we should always start. What is x the number of? X is the number of, yeah, T-boy, for the last one, if you put in 12 on binomial CD, if you put in 12, it will tell you the probability of less than or equal to 12, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, what we actually wanted was 6, 7, 8, 9, 10, 11, 12. We didn't want 0, 1, 2, 3, 4, 5. We wanted 6, 7, 8, 9, 10, 11, 12. And what the calculator's given you is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because that's what it does. It only does less than or equal to. So then if you then go out of that and go back in and say, all right, calculator, what's the probability of less than or equal to 5? That will then tell you 0, 1, 2, 3, 4, 5. and then you can remove that, and that leaves you with just 6, 7, 8, 9, 10, 11, 12. Okay. Yes, exactly. Yep. Find 12, find 12, then find 5, and then subtract. Okay, so what is x the number of here? Well, I'm going to actually write it next to it, because it's going to keep changing, and this is what happens, and this is why it's really important to keep writing it down and thinking about it. X is the number of red bands, and here's the other important bit. How many is it out of? Because that might keep changing. Out of 50. Where did I get that information from? Well, it's asking about red bands. So I want to count the number of red bands, and I've got a sample of 50. So n is 50. So when you go into your calculator now, you're going to tell it that n is 50. And you know you're talking about the number of red bands. And then the calculator will say, okay, what is the probability of getting a red band? Well, 0.18. The proportion of red bands is 18% of them. So the chance of getting a red band is that. So we're now okay. We've written down what x is equal to. We know how it's distributed. So you know what n is, you know what p is. You can put them into your calculator. The only choice that we now have to make is, are we going to use PD? And that's for the probability that x equals. Actually, I'm just going to write it like this. That's for equals. Or are we going to use CD, and that's for less than or equal to? That's our only decision. Well, this question says exactly 4. So if there's exactly 4, I'll go to the correct question before I start telling you wrong answers again. And they give these just as a sort of little warm-up, really. They give you a few where it's like almost like a warm-up at the beginning of an exercise class or something. Pick up your calculator, put these things in. So the answer is 0.02 623. Okay, let's speed it up a bit. At most 10. Now, I recommend that you always write down the little number line just to think. Okay, at most 10. So I'm going to go 8, 9, 10, 11, 12. Right, at most 10. Because there's so many ways you could phrase this. At most 10, not more than 10, less than or equal to 10. And you need to think every single time, just using your normal brain, not your maths brain, about what they're actually talking about. How do I translate at most 10? Imagine somebody asking you to buy at most 10. What could you come back with that they would say that's not what I asked for? Okay, so go into your calculator and think about what you're going to put in. Which one of these are you going to choose? What are you going to put in? And then we will see what you get. So I'm going to do it as well, this one. Okay. 0.7187. Anybody get 0.7187? Okay, we have 2 answers. This is perfect. This is what I wanted. I wanted 2 answers. Okay. 2 answers are answer number 1, 0.7187. Answer number 2 is 0.8801. Oh, look, it's 50-50. I love you guys. You're perfect. It's 50-50. Now, one of those is right and one of those is wrong. And I'm going to be a bit smug at the moment. And to those of you that have got it wrong, I'm going to say to you, do you not remember me saying once or twice so far today that it's important to write down what X is? Because it changes and you'll go wrong if you don't. Okay. Right. I'm going to start. I deliberately tricked you. Well, I didn't. I just didn't guide you to write down what X is, did I? I just carried on. And that's the problem. So let's go back and we'll see which of these answers is correct. Right. I'm going to use a different letter. Y. Y is the number of yellow bands out of 50. The number of yellow bands out of 50 is what I am asking for. Yellow. So what is N? 50. What is P? What is the chance of getting yellow? The chance of getting yellow is 0.15. You had to change your P to 0.15. Okay. You had to change your P. And then when you do that and you put in less than or equal to, and then you choose 10, the answer that you get, the correct answer was 0.8801. So those of you who got 0.8801, you are super brilliant. Those of you who didn't, and I hope you can see that even in this small class, it was 50-50. 50-50, right? And that is why, and that is what happens in the exam as well. And you know exactly what answer you are going to get. You don't need to look at student script to write the mark scheme. You look at the question and you go, right, so for part B, the wrong answer they're going to get is 0.77 blah. You just know. And so this training that I always put in with all of these topics is the training to stop you doing the thing that I know loads and loads and loads of students have done. So let's continue with that, and we'll make ourselves do it every time now. Next one. Z is the number of blue or green bands out of, it's still 50, but they might change it, out of 50. Okay. At least 30. So now we know what to put in the calculator. N is going to be 50. You can work out what P is going to be. Just have a look at the information you've got. At least 30. Just please make yourself do this. I know you're probably thinking in your head, oh, I can do it. I don't need to write out a silly number line. That's just silly. But honestly, I think of it as a little gremlin in my brain or in my pen, and the second that I stop concentrating, it throws something ridiculous in. So the second that I stop concentrating, the second that I relax, that I become slightly arrogant and I think that I don't make mistakes because I've got a really good degree in maths and blah, 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 then that's when I do something stupid, like I do 3 squared is 6, or I change a 5 to a 2. Or the other day there was an x squared, and the squared just on the next line, I just didn't write the x squared, I just wrote x. That sort of thing. And whenever I relax, that's when it can pounce and throw in these things that make us think FFS. So I'm going to write down the number line. I'm going to think at least 30 is this lot. At least 30. So calculator, I've only got the option of typing in less than or equal to. That's what the CD is. So your X would need to be 29. Now, when you get that result, less than or equal to 29, then you can do 1 minus because the whole thing adds up. Yep, Jacqueline's saying, could I work out? Oh, no, Jacqueline, good point. Can we do at least 30 blue and at least 30 green? That's going to be a different question, because if you did, what's the chance of getting at least 30 green, or is plus, or at least 30 blue, then what you're saying is that they all have to be the same color. Whereas if you combine them and just think of it, this is the thing, one of the rules for a binomial is that there's 2 outcomes. So there's always, when you're modeling it with the binomial, there's only 2 outcomes. There's either yes, it's blue or green, or no, it isn't. Yes, it's yellow, or no, it isn't. Yes, it's red, or no, it isn't. Always only 2 outcomes. So you have to define success to be one thing with a probability. So in this case, success is being blue or green. And then you go, yes, success. So the blue or green, yep, would be 0.5. 0.5. Because you're just basically merging these together to just say blue, green, it's, I don't care which is which. T-boy, does and mean multiply in maths, and or is add? Yes and no. Or is add, but it's very, very important that and is not times. And is only times if the 2 things are independent. It's how we test independence. So if we've got a thing A and a thing B, and we want the probability of A and as well B, then if A and B are independent, nothing to do with each other, don't affect each other, then you're right, it's A and as well B is the probability of A times the probability of B. But if A and B affect each other, if they're dependent, if one of them like makes the other one more or less likely to happen, if it's happened, then it is not times. So it's to do with independence. Okay, the answer is 0.101. I'll put it here. 0.1013. Well done, everyone. Okay. Next. Yeah, so independent events, the probability of A and B is the probability of A times the probability of B. If they're dependent, then the probability of A and B does not equal the probability of A times the probability of B. That's the test for independence. Right. I hope I have now trained you to think carefully and ideally also write down what X is. The thing, Jacqueline, in this case, the thing is that we don't have to, blah, blah, blah. It's not like a tree diagram situation. It's not like a tree diagram is I take them out and I go, right, is it green or blue? And then I put it on the side and then I take another one. It is kind of like that, but it's a very specific case of a tree diagram. So the specific case is that there's only ever two branches, either success or not success, success or not success. And then because one of the rules is that the P remains constant, the chance of success, then all the way across the tree diagram forever, it's the same two numbers. Success is always P, failure is always 1 minus P, always. So it just goes on and on and on like that. And then what the calculator is doing, and I think this is the next question, we'll see this, what the calculator is doing is it's going, what's the chance of that and that and that and that and that, or that and that and that and that and that, or that and that and that and that and that. That's what the calculator is doing. Okay. Right. So we're going to define X, and if I can make you do this, I have succeeded. X is the number of, well, it says not yellow and not white. So, okay, we have to be careful. What do you want it to be the number of? Because that's what we have to think carefully. Do you want it to be, there's two options. You can have option A, success is getting a yellow or a white. Or let's call it a yellow white. Or you could have success is not getting a yellow white. And it doesn't matter which one you say is success. It doesn't matter. We're still gonna get the same answer. What would you like? It's totally up to you. I'll go with whoever says first. Either we'll have the number of yellow whites or the number of not yellow white. What would you prefer? I'll do it whichever way you like. Number of yellow whites or number of not yellow whites? Yellow whites, okay. Number of yellow or white bands out of 50. Is it still 50? Yes. Now, here's my number line. 33, 34, 35, 36, 37, blah, 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 blah. 43, 44, 45, 46, 47. Okay. More than 35. More than 35. That's the cutoff there. Fewer than 45. That's the cutoff there. Fewer than 45. Yes, Lawrence, for C, you merge green and blue. So binomial always has only two outcomes. That's what the bi in binomial is. It's either success or failure. That's it. Yes, exactly, 0.5, perfect. Right. So the question says that we want more than 35, but less than 45, which is this group here. We've already seen how to do a group. Do you remember on the last one? We had this group between 6 and 12. So we asked the calculator to go all the way up to 12, and then we subtracted all the way up to 5, and that left us with just 6 to 12. So we've already seen how to do it. So it's just a case of now sticking it in your calculator. So Lawrence, for part C, what you should put in your calculator is N is 50. This is part C. You're going in binomial and you're going binomial. Oh, did you forget to do 1 minus? Look at the number line. When you do the probability that it's less than or equal to 29, when you put in X is 29, it doesn't tell you what you want. It tells you the opposite of what you want. And by drawing this out, you always know what you're finding from the calculator. So in this case, you do 29 or less, that's your X. And then you'd have to do 1 minus that answer. And then that's going to be 0.101. Right. Stick this in the calculator. So X is going to be 44 and 7. 1, 2, 44, 50, yellow and white, 0.2. What? X is 44, N is 50, P is 0.2. Huh. Comes out to be 1. Right, so things that will happen here. An incorrect answer is going to be the number 1. Because you can't just tell the calculator to just do less than 44. If you do less than or equal to 44, if you use binomial CD and you put in X is 44, it's going to do all of the ones all the way down to 44. And that is not what we wanted. Look at the number line. What we wanted is just these ones. So we need to take off 35 and down. So if we then do back, how do you go back on this? Oh, I see. Then we do X is 35, because you can see 35 and less is what you don't want. So you do 35. That gets you 1 as well. And then you subtract and you get 0. So I'm doing the thing wrong that you did before. That's what I'm doing wrong. Okay, I'm going to explain, right? I'm going to explain. And I'm going to get rid of most of this first, because I want it to be really clear what I'm saying, because this is really important. Okay. See how I defined it? I defined X to be the number of yellow or white bands. What's the probability of yellow or white? The probability of yellow or white is these two added up, which is 0.2. So X is binomial, the N is 50, and the P is 0.2. Okay. Now what I did is I just read this, and then I stopped reading. So I've drawn a little picture out, and I've drawn the picture and I've put the box carefully around more than 35, but fewer than 45. That's what I've done. Now that's not what the question asked. This is what I have done. I've read that bit and I didn't read any of this. This is what goes wrong. It's about clearly defining what your X is, clearly defining it, and then really thinking about what number line you need to draw and what is going to be put into your calculator. So let's have a look at that bit that I didn't read and see what it says. Okay. These are the ones, these ones here are the ones that are not yellow, white, not yellow, white. So this here is wrong. That's wrong, that X. I've said that I want to find that thing that I've drawn here, this. I've said, what is the chance that the number of yellow or whites out of 50 is between 36 and 44? So more than 35, but fewer than 44. That is wrong. That's not what I want. I want the opposite of that. And do you remember I said to you, do you want me to define X to be the yellow whites or the not yellow whites? Because it will depend, what we put in the calculator will depend on that. And it shows again how important it is to define it. So this is wrong. I'm going to change that. No. What we have, that just looks like an X. What we have here is actually not X. It's the opposite of X. X not. So, and here's the clever bit. How many X's? Let's leave our definition the same. How many X's do we actually want? Well, there's 50 altogether, right? So if not X is 33, 50 minus 33, probably should be able to do that in my head, but not very good at numbers, 17. This list is going to be important now. If there's 33 that are not yellow, red, yellow, white, then there must be 17 that are yellow, white. And then it goes down like this. And this is what we want. That's what we want. I defined X to be the number of yellow whites. The number of yellow whites that I want is between 6 and 14. That is because the number of not yellow whites is between 36 and 44. So the number of yellow whites is between 14 and 6. So this strategy of having the X and the not X underneath each other means that you can then translate the question from one to the other. Now, the other option is that in the very first place, we don't define it to be the number of yellow whites. We define it to be the number of not yellow whites, in which case P is not 0.2, P is 0.8, because we just add up all the other ones. And it doesn't matter which way you do it, you just have to know what it is that you're doing, okay? Right. The answer is, what bit is this? Let me make sure I tell you the right answer so you don't think you've gone horribly wrong. 1, 2, 3, this one. Yeah, 0.8913. Okay, the way that I got 17 is that these have to add up to 50. That's how it is, because there's 50 altogether. So if you're defining, this is the number of not yellows here, not yellow whites. If there's 33 which are not yellow or white, then there must be 17 that are yellow white. And these are the opposite of each other. And this is a very, very common structure of question. So what I just did is not unique to that question. It's very, very common to have a number line and then to be thinking, hang on, though, that's not what I want. I want the opposite of that. I want the ones that did burst if it was balloons bursting, or the number that did survive if it was that sort of thing. I got 33. Oh, this doesn't matter. I was just writing down a number line. I knew my number line needed to be somewhere around 35 and somewhere around 45. So I just randomly started there and finished there. Okay, moving on. Now, there is one thing which I have not told you, which is how the calculator is getting these numbers, particularly how it's getting the numbers when you ask it to do the CD. So that's equals X. When you ask it to do PD, it's just adding them all up. But when you ask it to do CD, it's using a formula. And you need to know that formula, and that formula is down here. So the reason you need to know this formula is that now and again they ask a question like this where you have to actually use that formula and you can't put it in the calculator. And you can't put it in the calculator because you don't know P. So you can't type it in because you don't know what P is. That's what you're trying to find. So you need to know this formula. So what the formula says is it's a simple formula when you think about it. We've got this success, failure. Success, failure, success, failure. Let's say I do a really simple one. I mean, it's not going to look simple in a minute, but this is 4 trials. N is 4. That's 4 trials. Trial number 1, trial number 2, trial number 3, trial number 4. Let's say I wanted to get 3 successes. 3. Success, 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 fail. Success, success, fail, success. Success, fail, success, success. Success, no, fail. I'm lost already on how many there would be. Success, success, success. Is that all? So what the calculator does is it works out what is the chance of success, 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 fail, puts it there. What's the chance of success, fail, success, success, puts it there. And it's okay to use times because these are independent trials. How do I know? Because that's one of the rules of binomial. So in this particular case, because they're independent, the chance of this and this is that times that. You just times them together. So the calculator can work these out. And then it needs to know how many different ways there would be through that tree diagram to get that possibility. So with a simple example of n is 4, and it's going to be success or fail. I could get, let's say I want to find out the probability of getting 3 successes. Success, 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 fail, success, success, fail, success, success, fail, success, success, fail, success, success, success. There are 4 ways. 4 ways. And that number there, 4 ways, that number is n choose r, or actually n choose x, I should say. I always forget to make it an x. N choose x. 4 ways. There are 4 different ways. So your structure of your equation of the probability is how many, let's say, like, well, you tell me, give me a make up an n and make up an x. Let's say the number of trials is first number I see popping up. N is 20, right? And how many successes do I want to find the chances of getting? How many successes? I can't, 8. I can't get 25, 8. Right, so think about the tree diagram. The tree diagram would have 20 layers, 20 different duns, 20. And then at each one, I could go down or up. And then I'm trying to get 8 successes. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That would be one route. Now, how many flipping ways are there? I could go 1, 2, 3, 4, 5, 6, 7, fail, 8, fail, 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 fail. Every single one of these is going to have the same probability. It will have the probability of success to the power of 8, because I've got 8 successes. And then it will have the probability of failure to the power of 12, because I've got 12 failures. And every single one will have the same. But how many are there? How many different ways can I write down 8 S's and 12 F's? That's what NCR is. That's what your calculator gives you. So there is a button. It's near divide. You go shift divide and you put 20, choose 8. Or 20, choose 12. It's the same thing. 8 successes and 12 failures is the same as 12 successes and 8 failures. I just have to redefine what success is. That tells you the number of ways. So that is what this equation is saying. The probability of success, the number of successes, the probability of failure, the number of failures, and the number of different ways that we could get that combination of successes and failures. So that formula is down there, and we can use it to answer this question. It says the probability that X is 0. So X, how many trials are there? There are 12 trials. So we have got 12, choose 0, P to the 0. P to the 0, 1 minus P to the 12. Oh, stop. Right, this is going to be our last one. We're just going to quickly finish this. This is equal to the probability that X is 0. Using the formula, not using, so N is the number of trials. The number of trials is 12. Choose none. I want no successes at all, none, not a single success. So that's 0 there. P is the probability of success. I don't know what that is. I'm just going to call it P. And then the power is the number of successes. So this is success chance, number of successes, none. Failure chance, number of failures, 12 out of 12. That's what your calculator does. But in our case, we know the answer. So you put 12 choose naught in your calculator. It will come out as 1. Anything to the naught is 1. You can do the 12th root and then rearrange. And what you should get is 0.221 for P. Right. There is one thing that I didn't do with you, but I'm going to explain to you how to go get it and find it yourself so that you can have a look. So if you go into the course and you find so you press content guide, go in there and then find number 53, 54, 55, AS 53, 54, 55. And those are the ones on the binomial distribution. It's going to take you a grand total of 30 minutes to watch these and make notes. So first of all, you've got binomial probabilities, which we've basically done everything, but there's just one style of question that I didn't show you. So what you can do is you can print the notes template out there. Here's the questions that we were doing. There's the one on the bands that we did there. And the mark schemes are at the bottom, so you can go back over that and check them. There's only these 3. The only thing that I didn't do with you in that session is the ones that I call current bun problems. And current bun problems are, this is like my current bun drawing here. Current bun problems are ones, well, you'll see when you watch this video. It's only 10 minutes long, okay? So that's the only thing I haven't done with you. Is the current bun problems. Everything else we've covered. So I would say it's totally up to you. It's your day, but I would say if we're going to stick with our aim, which is to get all of the AS notes covered, all of the content covered by the end of next week. So we did the pure, we've got 3 more weeks. We did a week of pure. Now we're doing some stats, then mechanics, then we're going to finish the pure. So the stats, we're going to tie it all up this week. So I'd really recommend that you go in and have a look at those, make some notes and try some questions out yourself. Tomorrow, we are going to look at hypothesis testing. Okay. So hypothesis testing is quite a big topic and you do it in the second year as well with the normal distribution and with correlation. So it is quite a big, important topic and it goes on the end of the binomial distribution. We use the binomial distribution in hypothesis testing. Thank you so much for all turning up. You are, I know I say this every time, but you are, you're great for doing this. You should be really, really proud of yourselves. Zeph, what does the value that the binomial distribution gives you actually mean? Do you mean NCR, or do you mean if I put it in here and I put in N and I put in P and I put in X and I press equals? If you mean the first one, NCR, what that means is the number of different ways. If I have N options and each option is either A or B, A or B, A or B, A or B, and N of them, then the N choose R is the number of different combinations of picking R successes. So if I've got 15 and I want to choose 5 yeses out of those 15, each of the 15 says yes or no, and I want to choose 5 yeses. I could have that one, that one, that one, that one, that one, or that one, that one, that one, that one, that one, or that one, that one, that one, that one, that one, or that one, that one, that one, that one, that one. 15 choose 5 is the number of different ways I can choose 5 from 15. Okay, right, tiny break, timer on. I'm going to go downstairs, reheat my coffee because it's gone cold, and I will, if you're in the second year, I'll see you in 5 minutes for normal distribution. If not, I will see you tomorrow. I'm going to take my, I don't know, we're still playing around with what's useful on YouTube and what's useful in the course. So the study with me that I'm going to do at 4 o'clock, I'm actually going to do that inside the maths course, but I will put a link in the exambulance. So if the exambulance is free, I'll put the link in the exambulance and in the maths course, and you can get in at 4 o'clock if you want to do that, rather than me streaming it on YouTube. But we'll just see. We're playing around at the moment with what's helpful for people. Okay, see you later.